Okay, when we have the material with low albedo, we call it a small U value, the heat arrives. We can see the yellow line here from the solar radiation. Heat arrives. Artificially, it will be reflected as a short wave. But when we are having the very dark material, it's going to be absorbed in the surface of the material. It can be only release heat during the night. So this is what we call urban heat island. In most city in Indonesia, when we have very dense area like Jakarta, Bandung, not Surabaya, but Jakarta, Bandung, and another cities, we have very big population, but less open space. So the heat trap, and we can see the yellow area here. That's we call it urban canopy layer. The people feel the heat. So it looks like a ping pong area, and then the heat stress goes to the people during in the urban area. So when we take a look our material, actually our eyes see the same color, the gray, the black one. But when we take a look with the full camera, the thermal camera, we can know the difference. What is the difference between the greenery, between the asphalt, and between the surface of the building? So when the albedo, which is we call it a lack of evapotranspiration, the material going to absorb and store more heat radiation. The asphalt say here it can be like 66 degrees Celsius, but the greenery we can take a look here like 40 degrees Celsius. It means like we need to make the diversity of the material when we generating heat store in the outdoor urban space, people going to feel not so comfortable. So it's going to be like only during the afternoon. So in Jakarta and Bandung where I live, the heat trap inside the city, it's going to be released around 2 p.m., not released during the 6 p.m., but 2 p.m. So the heat really, really trapped inside the city. So this is the idea. When we know that heat transfer from the solar radiation, can we make our material much more friendly for the urban outdoor area? When the absorption, we're going to make it reflected. So the idea when we have the material with a higher solar reflectance, it's going to allow less heat to be transferred to the environment and also to inside to the indoor area. So also the most important thing is the thermal emittance. It's going to be only during after the sunset. So when we have the dark color, dark material, heavyweight material, it can be also make the emittance the ability to emit is really really less compared with the light material. So we need both of the reflectance and also emittance to make our surrounding area, the urban outdoor area, much more nice for the pedestrian. So this is the albedo, what I'm already talked about the previously. In some Asian country, they like to use the like corrugated roof, color paint. We always having the preference like dark color. Like when we using the tile, roof tile, we use the brown or black. So the red brown tile, they only having the U value around 0.1, means they only can be reflected zero point 0.1 and they absorb zero point 0.9 of the solar radiation. The asphalt is much more severe The albedo or U value, they having 0.05 means that nearly 100% they absorb the heat. So when we having the material with the high U value means high albedo, it can reflect the solar radiation. So we need the high solar reflectance index value.
Pak, 9 bang. Ayo bang, 90 nih.
Sorry, perhaps you can mute your audio. The participant perhaps can mute the audio.
Aduh, belum di-mute lagi.
Okay, this is what is the high albedo material. We call it cool material. We have the high reflectivity and high emissivity, which is can effectively reflect a fraction of the solar radiation back to the atmosphere. So don't confuse with the how to say like the green gas emission because of the glass emission. This is the atmosphere is we call it is very long wave. It's not in the surrounding of the Earth anymore. It will be back to the space. And then our when we use the cool material, it can be cooling energy saving up to 2.9 kilowatt hour per square meter. So when we say like we can reduce the average reduction in the temperature like 3 degrees Celsius, it can be making the energy saving for the indoor thermal operative temperature. So for the surface temperature, we can reduce up to 11 degrees Celsius. This is highlighting cool facade as a viable technology for improving energy efficiency and environmental quality in hot and humid climates. So this is we call it startup in our university. We try to produce ourselves from our research, become the uh, scalable, massive product for Indonesia. So when we take a look the numbers here, solar reflectivity, they have 0.84 means that 84% they can reflect to the space. And then the thermal emittance 0.9 means that 90% they can emit also to the space. So after 3 years, uh, the reflectivity going to reduce 0.77 and then the emittance going to reduce 0.88. This is like aging after using for the 3 years. So this is another our startup product in our university. We used the collaboration with another company. We make the cooling panel, cool panel. So this is directly can be applied to the housing system. So I can show you the application. It's already all for the cool roof. We make it all around Indonesia from Sumatra Island to NTT, Nusa Tenggara, East Nusa Tenggara. And also this is our new project, the cool house. This is the cool panel. The outdoor set like 37 degrees Celsius and the indoor is 28 degrees Celsius. So you can imagine without any insulation, the remarkable significant reduce of the temperature is very uh, high, the gap. And this is our Be Cool project. We try to cover 15 until 20 houses, or this is 16 houses. So the coverage is 2,700, around 2,700 square meters. And we can take a look here, the comparison between the air temperature before, we can take a look, air temperature is indoor, before is 49 degrees Celsius and after is 35. This is indoor temperature. And then surface temperature before is 51 degrees Celsius and after is 46 degrees Celsius. This is globe temperature. We call it radiation temperature. Before is 43 and after is 39. This is another spot also having the decreased air temperature, surface temperature, and also radiation temperature. This is another spot. All spot here in one city, one area. We can say that when we use the cool material, we can cover the microclimate much more nicer, and indoor temperature much more cooler compared before. This is another city in Gorontalo within 12 houses, also having the significant reduction of the indoor temperature. Also, the humidity level also decreasing. This is another project in Makassar City in Sulawesi. So it's also uh, in Makassar City, it's very unique compared with the other cities. So when we use the cool material, we need to find, we need to know that our situation have to be vacant, not vacant, but have to be not too close each other. I mean, like the house can be not so dense in this area, since the density of the houses is very very big. So we can see here, even surface temperature is decreased, the outdoor temperature, like radiation temperature, is not really help a lot. Like this one, the outdoor temperature is not really decreased a lot, because there are some of the gap and some of the storage and some of the trap of the heat cannot be released by the air. So this is another struggling if we put this material in the high dense area. And when we try to collect what about the low carbon material, we calculate three sample of our house. We compare with the normal house in Indonesia, like this. We compare our material, and then we make the comparison between the embodied energy and CO2 emission per year. This is the result. So compare with the normal houses in Indonesia. This is our embodied energy is very promising because we avoid the heavy structure like stone, brick, concrete. We really avoid that material, so we can make the the low carbon material much more lighter. I guess the closing remark here is because the Indonesia lies in a hot and humid climate zone with the daily sun duration like 10 until 12 hours. We need the material with the solar reflectance index with the very high SRI. So cool roof is one of the alternative for to improve the surrounding, and also to improve as the urban heat island countermeasure in urban area with high diurnal temperature. I guess that's all for me. I return to Noe again. Thank you so much.